engineers. And as engineers, we need science to solve problems and questions. Now take a look at this. Look what happens to the screen as soon as I move it. The screen responds. The question is, how does it do so? I mean, it doesn't have eyes, ears, or nose like we do. But somehow, this non-living thing can actually sense the surrounding. Why does a smartphone respond when we touch it? How do ATM machines know how much money we put into it? And the answer is this. Electronic sensors. So what I'm going to show you today is how we can connect the real world and the digital world. Let's begin. Can I have one spotting volunteer to come up on stage? Please. This one you do? Alright, you, come on. What is your name? Tan. What you have to do is to pour water into this empty bottle until I say stop. Alright? Hang on. Alright. Pick your favorite color.
Purple.
Purple. Alright, I connect it to the circuit. Alright, keep going. Pour more water until the wires touch each other. Keep going. You're doing great. As you can see, the buzzer beeps when the circuit is completed. Water is an electrical conductor. The circuit is such that... Alright, you may return to your seat. Thank you. The circuit is designed such that when it is completed, when the buzzer will beep, you can connect it to a light bulb or any other thing. And I'll turn this off for a while. Water is an electrical conductor, and if you have your hands wet and you touch the power supply, you will get electrocuted because water is an electrical conductor. Look at that guy, he's getting electrocuted. Water is an electrical conductor because it contains free moving ions of hydrogen ions and hydroxide ions. Here's the circuit diagram. As you close the switch with water, the buzzer beeps. Again, the battery provides the current which will try to flow from the yellow colored wire through the water, through the purple colored wire, and back into the circuit. And so it completes the circuit and the buzzer beeps. So that is demo number 1. Now let's move on to the next demonstration. May I have another spotting volunteer to come up on stage? Please.
Naif.
This one will do. Hang on, I'll set up. What is your name? Emma. Miss Bubble. What I'm going to set up is a sophisticated water level detector. Alright, what you have to do is to pour this white liquid. It's nothing dangerous, just uranium and plutonium. Just kidding, it's milk. It's just pure milk. Right? As you can see, this water level detector is much more sophisticated. There are no wires dangling around like intestines on the bottle. Yeah, for it slowly. Don't feel it. Unless you want to have an explosive performance. But this is Twin Towers. They don't like it. Keep going. Keep going. Yes, yes, stop. Oh! So what's happening here? Any idea? Alright, what we have here is an infrared sensor. Infrared sensor, and here's the emitter. Look at the screen. On the left hand side is an emitter, infrared emitter, which will emit infrared light on the liquid surface and will reflect back into the detector. So as the detector detects infrared light, it allows current to flow, and it's just the same circuit as before. So it will allow the buzzer to beep. Alright? So you understand that? Yeah. The thing is, infrared light reflects. Alright, you may return to your seat. Thank you. Infrared light reflects. And where do we see this application in our everyday life? In the Petrosains toilet. When you go to the toilet, you use the tap, you put your hand under the tap, and the water flows. It's using the same concept. And another application would be our car sensor. When you reverse your car, it goes beep, 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 right? It's using the same sensor, infrared sensor. Sorry, I just... Now let's move on to demo number 3, which is air piano. Those of you who love to play musical instruments, you will love it. Can I have one spotting volunteer?
Patini. Again.
Right, thank you. What is your name? Barry.
Chomel.
Do you like to play instruments? Musical instruments? What kind of instruments do you play?
Guitar.
Guitar. Is piano okay? Right, I'll set things up for a while. Alright, you will try it?
Twinkle little star. Come on.
Put your hands in front of it. You have to be flat because it depends on the.
Come on.
You need to put your hand flat because it depends on the reflection. Right, thank you very much. So, how does it work? The infrared light reflects, that we know, but how does it play different musical notes based on the distance of my hand from the sensor? And the answer is the intensity of infrared light is inversely proportional to the square of the distance from the source. This means when I put my hand away from the infrared detector, the intensity detected by it will be much lower. Agree? And when I move it closer, the distance decreases and the intensity increases. So that is why it is able to detect the distance of my hand based on the intensity of the infrared light reflected. Have you ever seen anything like this in the market before? No, right? Right. Let's move on to the fourth demonstration, which is a simple coffee maker. Can I have one more volunteer to come up on stage?
Bob.
Please. Alright, you there, come on. Give him a round of applause. What is your name? Naga. Do you like to drink coffee? What kind of coffee do you like? Cappuccino. Cappuccino and coffee. Kopi kau. do you go to Mama? Anything? Alright. I love coffee. And to make a good cup of coffee, we need the right concentration.
Yeah.
So, hang on. I need you to make a cup of coffee. I'll explain. This thing here is an LDR. It's really small. Electronics can be really small sometimes. It's an LDR. So as the intensity of light that falls on it increases, the resistance of the LDR will decrease, and vice versa. So what you're going to do is to make a cup of coffee with this cup on top of it. Right? It's new. With water. Yeah, hold on.
Oh.
Wow. Alright, you may begin. Make a good cup of coffee. Pour the coffee powder into it and stir at the same time until it reaches a certain concentration and something will happen. Alright, you may begin. Keep going. Stir. Go ahead and stir. Stir quickly. Keep going. Add more until it reaches a certain concentration.
Pour everything.
Pour more.
Pour.
Keep going. Dance. We're having a good party. Keep going. Alright, you may thank you. Time for science. Alright? The absorbance of light by a colored solution is proportional to the concentration of the solution. So as you increase the concentration of the coffee, less light is able to pass through it, which falls on the LDR. So the LDR increases its resistance to a point of triggering a switch which then plays a music. The point is, the absorbance of light is proportional to the concentration of the solution. And that is how you make a coffee maker with just an LDR. Let's move on to the fifth and final demonstration I have for all of you. I have saved the best for the last.
Ooh. Wait.
This thing here is called a Microsoft Kinect, and it is very popular in the market nowadays. It's usually used for gaming purposes, but today we are going to use it to control the robot based on your hand gesture. And it is based on this principle of reflection of infrared light and also the intensity of infrared light is inversely proportional to the square of the distance from the source. Now, my brother is trying to set up the Microsoft Kinect. It's really cool. You can see as he moves his hand. Keep going. As he moves his hand, the robot moves as well.
Don't bang.
Stop! It's going to break! Oh, okay.
Reverse.
The robot is responding to his hand gestures. How magical is that?
Woo! Come here.
You need a better player to play this.
Not enough distance.
Control it. It's not moving. I think it's stuck.
The distance is a little bit too near. Wait, huh?
You're having a little of a technical problem. I think Petrosains is willing to put one of these cool robots in their exhibition. Am I right?
Yes.
Well, my beloved audience, you may play with it after this for a prize.
Yeah.
I think the battery is dead.
Now he's blaming the battery. Alright. Time for science is based on the Microsoft Kinect is based on the reflection of infrared light, and also that the intensity of infrared light is inversely proportional to the square of the distance. I'll explain further. Just now, the sensor had only one receiver, but this Microsoft Kinect has tons of them. So in a sense, it is able to detect various intensity on the hand, reflected on the hand. And it is able to, the data is sent to the computer for processing, and then it will sense it as a hand gesture. It is able to detect the contour and shape of the hand. So, time to wrap things up. Electronic devices detect and sense the surrounding using clever innovations based on solid scientific facts. Electronic sensors are the sensory organs of the non-living things. So be careful next time when you think you're alone, because someone or something may be watching and listening. Alright, finally it's moving again. Turn to the audience. Alright. Thank you very much.